Okay, we're going to pick up at the filter. Here we have the 33 slices. Here you can see the sawtooth wave with all harmonics and the square with every other harmonic. And here we have the 64 harmonics. So 64 would be along here. In other words, this rectangle would be right here. Okay? And to start out with the buttons we have, I'm going to go to Tools, excuse me, and I'm going to zero them out. And what's happened is all the filters are at the minimum setting and they're so precise that you can't see anything. And we've succeeded in filtering out all the audio from all the slices. Okay. Now if I were to open up this filter, okay, that's harmonic 0, and it's down at the bottom on the spectral content chart or display. And we can go along here and see how as I go from left to right, we go from bottom to top. Now you also need to know that polarity doesn't matter from an audio perspective until you get into more complicated editing. In other words, let me go back and zero that. In other words, if I open up a filter on the positive side and open it on the negative, for right now it sounds the same. And these are fringe concepts that I don't know much about. But polarity does come into play when you start talking about canceling other things out, sound that you're combining with, or in a complex wavetable. Okay, where should we go from here? Let's keep talking about the Tools button. Full. It opens all the filters to a positive side. All the audio is coming through. And this is going to be an optimized, or we discussed earlier, kind of like a normalized situation. Let's go back and zero them. And if I just choose a really small amount, it's still, it's like I did it up here. It's because if it takes a small amount, it will normalize it. If all my items are really low, it's just like I opened them all the way up. And that's due to optimization. Some form or closely related to normalization. Alright, let's explore the tools. Full, we did that. Tools 0 turns them all to the min setting. Tools invert. Well, there's nothing to invert, so let's make something. Okay, tools invert. Tools unipolarity. Let's go back and do something like this. Okay, makes them all positive, like an absolute value. Been through this concept 3 or 4 times. Normal, normalizes it, pushes it up to the top. Okay. That covers tools. Import. This is where I can take the harmonic value of another sound and impose it on my sound. We can use either a wave slice, a single cycle wave, or we can use a slice out of a wavetable. Let's try both. Okay, this is the first time we've seen this. This is the harmonic content of this single cycle wave. I'm reading over here what these nomenclatures say. This appears to be this appears to be this must be this. So, okay, we're going to apply the harmonic content of CZ001 to our sound. And that was the same thing we saw on the previous screen. And this is what it looks like when it filters our sound. That's what it sounds like. I believe you can achieve vocoder effects with this. Put a synthesizer sound in here, then have a person talking, filter it. Alright, let's go back and I wanted to show you importing a wavetable. So file type, I like to use these. So there's an interesting one. Now I have to choose only one slice to filter with. So they've given us the source buttons. I can choose any slice out of that wavetable. And we have the same functions here. File, wavetable. File slice, that is a little different. Bands. Okay, we've applied the harmonic signature of the slice of that wavetable onto our sound. If I like it, I can press apply. Let's go through some more buttons. That covers it for import, envelope, filter shift envelope. I was experimenting with this, and this seems to shift frequencies more than it does filter. Right now it's flat. Let me introduce this. See how it shifted it down and shifted it up? It's more of a shift envelope than a filter shift envelope, but anyway, if that helps it make more sense. See how it's shifting everything? And intensity increases the amount of displacement. Intensity cycles through different values. You can see it up here. Randomize. Randomize the polarity only. Smooth out. We have the limit functions available. We can only draw in the limited area. And then I can choose to apply the effects if I wish. Yeah, we did envelope. Filter blurring factor is a value we can cycle through, and I've not been able to hear its effect. 2, 3, 4. I don't hear it, so I can't find online an explanation for it, so that one's going to bear further study. Polarity lock, again, this is the one where Matthias says try it, see if you like the sound of it. If not, cancel it. So, looks like we canceled a lot more than just that. Anyway, that's an A-B comparison that you do by ear. Randomize. Randomizing the filter. Random polarity. And we've discussed limit previous times. Apply would apply our changes. And we're back out here. Let's undo that. We're back to our square to sawtooth. Let's try for shift. Format. It's kind of like imposing a vocal type effect on it. Let's increase the intensity so we can hear it better. Okay. Algorithm, continuous or discontinuous. Let's see if we can ascertain what that means, because I really don't know. Let's get back to where we were there. Let's try algorithm change. Okay, that did something. Interesting. We've covered algorithm, intensity, polarity lock. That's an A-B. You test. See which one you like. Here we have the on-off indication. Let's turn it back off. I'm not hearing much. Randomize the envelope. Randomize, this might give you some nightmares. Randomize polarity. Smooth out. Tools. Nothing here we haven't seen before, but we're applying it to the form and shift envelope. Static, we've seen that before. Let's cancel. I'll draw something. Static seems to latch on to the beginning or the end and make a straight line. I can't tell you any more than that. I'll have to experiment. Let's see. We know reverse, and we know mirror. We've seen those before. Normalize. SE line. Segment. Gee, I don't know. It seems to be very similar to static. Let's try some experiments. SE line. It made a straight line out of the average of the curve, I would say. Yeah, something like that. Whereas static just makes a horizontal line, it seems that SE line can draw a straight line at angles. Bad example. It's not doing it anymore. Why? Here, it's got a little bit of a curve to it, or angle. Let me try it a little bit more. There we go. I think I had my last harmonic was not drawn down to the bottom. Okay, we can apply or cancel. I think we've covered all of those. Now, symmetry modulation generator. I believe this wipes out. No, it doesn't, because there's our saw, and there's our square. I'm not sure if it uses our old wavetable or not, if it just completely generates a new one. And this is what it looks like. This is what it sounds like. Maybe it's imposing symmetry on our wavetable. I don't know. Width plus and minus. Definitely some ways to get some motion in the sound. Dampening. Oops, I'm not going anywhere. By the way, width was modulation width displayed here. Dampening, whatever is displayed here. Spread, partial spread. It's doing something, I don't know what it's doing. And shift. And reset. So, fertile ground there for experimentation. Interpolate. This is when we need to create transition slices between our source slices, and that's how I made this wavetable. I put a sawtooth here, a square here, and I actually used this screen to make it. So why don't I recreate that situation? Flash to memory. Let's go to assemble, and we'll put the sawtooth here, and we'll put the square over here, and we'll go to table editing functions, interpolate, and I'm just going to apply it straight as it is. We're going to interpolate from this one to this one, and this is what the output would be if I choose to apply it to the actual file. We can hear it. So it created all these transitional, and if I had more defined slices, it would transition between each defined slice. Why don't we do it? Let's put a sine wave in the middle. Okay. There's a sine wave. It's only got one harmonic, right? Okay. RAM wavetable. That would be up here. Slice. I'm not sure where I can. Oh, it's right there, the arrow. I can hear a slice. That's our square. That's our sawtooth. This is our sine, which is hard to hear. Okay, so I can hear the RAM wavetable without transitionals. I can hear each slice individually. Anchors. I don't know what this is. Slice setting. Anchor. I guess. Well, I really don't know. Sorry. It sounds like it played this one and this one, but it never played that one. Don't know. Polarity Lock again is an AB. Turn Polarity Lock on and turn it off and see which one we like better. And I would apply it if I want, and why not? Okay. Here we've got sawtooth harmonics, sine harmonic, square harmonics. What did we just cover? Interpolate? I think we did. No, we didn't. I didn't do algorithm. Stretch and interpolate, or interpolate. Let's go in and try to do a stretch and interpolate. Oh, that does look different. Not really sure what it did differently. It stretched something. Sorry, I don't know. Optimize. I do have some text here. I think we've covered everything in interpolate as best I can. Optimize. Stand by. I've got to read it up here. I'm going to read Matthias's own words. KTERM has an internal resolution of plus or minus 127 steps. But the dynamic of a 64 partial additive engine is much larger, too large to use it without artificial limiting. A saw would be 50 times the amplitude of a single sine. Optimize adapts the partials to the limited waveform amplitude. And here we're going back to my analogy of normalizing. In most cases this can be done automatically, but sometimes manual correction is required to get the best results out of the limited dynamic range. So if it's really quiet, I guess optimize gives you a little help with the normalizing / optimizing process. I don't think you'll hear it unless it's a really low volume. Okay, blur. I know what blur does. I'm going to show you. We're going to make a new wavetable. I'm just throwing a few square wave slices in. And we're going to try blur, and you'll see what happens. See, we've got 4 squares with odd harmonics, peaks on the odds. Blur, it created some nearby partials, lower in volume, so it kind of fades in over time. Let's go back to just those. Okay, blur once. We've got 1 slice on each side. Let's blur it some more. Okay. Random data. I think the wavetable is randomized in every possible way. I mean, you could go back and try and filter out something that sounds interesting. Boy, have we covered it. I think we have. Well, any questions, leave them in the YouTube comments. I believe this finishes KTERM for Audioterm. Thanks.